Now in this lecture we will look at various methods for the preparation of phenol, lab preparation methods and industrial preparation methods, right? So first let's go through lab preparation methods. In the lab, phenol is prepared from compounds of benzene, right? So first we will prepare some compounds of benzene, and from those compounds we will prepare phenol. So first compound that we will be looking into is benzene sulfonic acid. For benzene sulfonic acid, this is the formula SO3H, right, is prepared by treating benzene with oleum. Oleum is your H2S2O7. This is sulfuric acid plus sulfur dioxide, right? So this is like sulfonation of benzene to form benzene sulfonic acid. Benzene sulfonic acid is fused with sodium hydroxide, right, where it gives you finally sodium phenoxide. And sodium phenoxide is hydrolyzed with hydrochloric acid. It is treated with dilute dilute hydrochloric acid to give you phenol, right? The second method is from benzene diazonium chloride. We know that diazonium chloride, these are salts, right? Salts that are prepared from aromatic amines. Aromatic amines, by treating aromatic amines with sodium nitrite and hydrochloric acid, or we say by treating it with nitrous acid, HNO2 at 273 to 278 kelvins, where it gives you benzene diazonium chloride, right? Just remember, just look at the benzene diazonium chloride. These are unstable salts generally, right? These are unstable salts, so these quickly react to form your phenol, right? You can see you have plus sign here. When we say diazo, di means two, azo stands for nitrogen. So you have two nitrogen here in benzene diazonium chloride and chloride Cl, right? So benzene diazonium chloride, that's unstable salts, just remember that. And azo means nitrogen and di means two. So you have two nitrogen here, two nitrogen atoms, right, connected via triple bond. So this benzene diazonium chloride, which is obtained from an aromatic amine and nitrous acid, will undergo hydrolysis with dilute sulfuric acid to give you phenol, right? Just remember two steps. First, you prepare benzene diazonium chloride by a reaction called as diazotization. The preparation of benzene diazonium chloride from aromatic amine and nitrous acid is diazotization, right? The product obtained, benzene diazonium chloride, which is an unstable salt, will undergo hydrolysis to form phenol, right? Then comes your Grignard reagent, right? We have done Grignard reagents in previous chapter, right, in alkyl halides, right, and aryl halides. So we know that various organic compounds can be prepared from this Grignard reagent, right? So you have phenyl magnesium bromide, right, in which phenyl magnesium bromide, if you look at this reaction, this means this phenyl magnesium bromide in dry ether, right? You pass oxygen gas through it, you pass oxygen in phenyl magnesium bromide, which is in dry ether, right? We know that we need to have absolutely dry conditions if you have Grignard reagents, because Grignard reagents will break in presence of water to form your hydrocarbons. It will immediately form benzene if we don't use dry conditions. So that is why dry ether, you pass oxygen, it forms phenoxy magnesium bromide, OMgBr. Then phenoxy magnesium bromide will undergo hydrolysis to give you phenol, right? I hope this is easy, right? This is easy to understand. I repeat, this is your Grignard reagent, which is taken in dry ether, oxygen is passed through it, it forms phenoxy magnesium bromide, which undergo acid hydrolysis to give you phenol, right? Then comes your from Cumin. Cumin, first understand, Cumin is a compound, right, which is obtained from your propylene, right? It is obtained from propylene and it is isopropyl benzene, basically. It is isopropyl benzene. This is your CH3CH right? So what you will do is, I'm sorry, you're missing one 2 here, right? You treat it with, this is your propene, right? First understand this, the formula of isopropyl benzene, which is your Cumin, right? This is your Cumin. Let's see how to prepare this first. You treat this with benzene, right? When you treat this with benzene, it will form compound like this. It's this is your Cumin, right? We call it as isopropyl benzene. You can look at this compound. This is your isopropyl benzene, right? You have a carbon, you have a chain here. This is in side chain, right? So 1 2 3 isopropyl, right? Since this is in branch, that is why it is iso, right? Propyl benzene. So this Cumin, right, in presence of air, right, will form Cumin hyperperoxide, right? Cumin is oxidized to Cumin hydroperoxide. Now this Cumin hydroperoxide will undergo hydrolysis to give you phenol, right? Just understand the formula, learn this formula of Cumin, right? Cumin is prepared from benzene and propylene in presence of phosphoric acid at 523 kelvins. Cumin obtained is oxidized with air at 333 to 353 kelvins to give you Cumin hydroperoxide. This compound is your Cumin hydroperoxide, right? Now this will undergo hydrolysis to give you phenol, right? I hope this is clear. So these are lab preparations. Now coming on to industrial preparations, we have two important processes for industrial preparation of phenol. First is Dow's process, the other is Raschek's process, right? In Dow's process, what you do is you take chlorobenzene, treat it with sodium hydroxide at 623 to 320 kelvins, right, where it will form sodium phenoxide. This sodium phenoxide, on treating with dilute HCl, will undergo phenol. It will form phenol, right? I repeat, in Dow's process, phenol is obtained from chlorobenzene, right? Chlorobenzene is treated with sodium hydroxide, right, at 623 to 320 kelvins, right? Then it will form sodium phenoxide. Sodium phenoxide, when treated with dilute HCl, it will form phenol, right? I hope this is clear. This is your Dow's process for the preparation of phenol, right? For the industrial preparation of phenol. Remember, Dow's process is industrial preparation of phenol, right? So this is 320 atmospheres, 623 kelvins and 320 atmospheres. The second important process for the industrial preparation of phenol is your Raschek's process. In Raschek's process, you take benzene, right? You pass benzene vapors, hydrochloric acid and oxygen over cuprous chloride catalyst at 500 Kelvin, where it forms chlorobenzene. Now from chlorobenzene, you do hydrolysis of chlorobenzene in presence of silica at 700 Kelvin, where it forms phenol. This is also industrial preparation of phenol, right? Remember the name, Raschek's process. In Raschek's process, just remember, you will prepare chlorobenzene, right, from benzene by passing benzene vapors, hydrochloric acid, HCl and your oxygen over cuprous chloride catalyst at 500 kelvins, where it forms chlorobenzene. Now this chlorobenzene will undergo hydrolysis in presence of silica at 700 kelvins to form phenol, right? I hope this is clear. So just remember, preparation of phenol, lab preparation from benzene derivatives, from compounds of benzene, and industrial preparation from Dow's process, right? When we say compounds of benzene, you can see benzene sulfonic acid, benzene diazonium chloride, phenyl magnesium bromide and this Cumin, this compound, all are prepared from benzene, right? I hope this is clear. Thanks.